wanted to just talk about this briefly today because in class.
Sorry, I had to start the recording.
No, you're fine. I forgot that happens. In class, we've been talking about MCSs and some conditions favorable for squall lines and severe wind damage. And there was an interesting case in the Northeast a couple days ago. So I just want to very briefly go over it just to apply just a few things we talked about in class so the students can see kind of a real-time example or a near real-time example. So for those who weren't aware, on Wednesday, a couple days ago, the Northeast saw mostly a severe straight line wind event. There were a few hail reports kind of in the Delaware, Jersey area, and a couple weak tornadoes near the Connecticut-New York border. Wow. So I mostly am going to focus on the wind reports just as that's most relevant to what we just talked about. But yeah, this was kind of an interesting day for those living in the Northeast and along the coast. So just for your reference, many of these wind reports, which I didn't include all of them here because they were most numerous, were about after 1630Z until about 21. So I'm going to focus mostly on the 18 to 19 Z time period. And then just for the forecast, this was a really well forecasted event. There was a slight risk issued by the SPC the day before, and most of these fit into that zone. So this was a pretty well forecasted event. And part of that reason is the cold front was really the primary focal point for convective initiation and organization during this event. So this is just kind of a zoomed in mesoscale discussion summary issued by SPC that was valid after about 16Z in anticipation of these storms forming kind of out ahead of this cold front with the potential for damaging wind gusts kind of over the Jersey, Connecticut into Massachusetts with time. And then further to the south, kind of looking over the Delaware region and over eastern Maryland, similarly out ahead of this cold front, expecting the potential for some damaging winds, which as we saw had verified. So I just very briefly wanted to check out the sounding New York sounding. This was 12Z that morning. And so just a couple of things that we've been talking about in class and pointing out. One of the first things we've been talking about, thinking about organizational mode, is looking at the magnitude of the bulk shear from 0 to 6 kilometers. So the value at this time is about 37 knots, which is 19, 20 meters per second, which is kind of the upper end of what we do expect for potentially multicellular convection. We see the lower levels, the values were much weaker. And then you'll notice that just really minimal surface-based CAPE in this region, although there is not too shabby mid-level lapse rates that could promote some deep convection, although having it being surface-based initially was going to be a challenge. So looking ahead at 0Z, this is after the cold front passed through. So this isn't going to tell us too much about the convection that forms along the head of the cold front, because as you can see by 0Z, this whole thing was offshore, and any storms associated with the cold front were off the coast. So I'm not going to go too much into detail, other than this is kind of a classic sounding that we would expect following that cold frontal passage. And then looking further south, this is over Wallops Island, and looking at further south where we know there was also some severe wind reports, and it's kind of a similar story here. You have pretty moderate shear in the bulk layer. And then surface-based CAPE and even most unstable CAPE is quite limited, primarily to the lower to mid levels. So this is kind of a marginal case. It's not a surprise then that SPC thought about this as a slight risk on this day, but still potential for some organization of some convection that could fire up. So let's look quickly aloft. This is the 500 millibar map at 12Z for that morning, and you can see the trough moving across the region. And this is important because as this trough progressed throughout the day over the course of the next 6 hours or so, we see the manifestation of this at the surface, and you see this deepening low off in the Northeast. So here at 12Z, you can see the low situated over Maryland and central Pennsylvania, and then with time you can see some deepening. And the reason I wanted to especially pay attention to this is really thinking about any potential for the increase in the lower level winds and potential low level shear increases. So here you can see out ahead, we've got 15 knot winds or so, and then there's a slight increase. I know it's a little bit difficult to see the barbs here, but increasing to about 20 knots here at the surface. So you can see at the deepening of pressure, it's increase of the onshore flow, and we'll see this and how that manifests and contributes to the convection that developed in this region. So if we zoom in, we can see this even a little bit more clearly. So this is the surface station map here at 18Z and the one for a couple hours later at 20Z. And again, let's focus here primarily on this Connecticut, Massachusetts region, where winds are primarily out of the south. It's a bit of a westerly component. And again, you can see there are some here now about 25, 30 knots after that low pressure is deepening with time. Another thing to point out here and why this was kind of initially sort of a marginal case, while temperatures throughout the day did increase into the mid to upper 60s, it's not really widespread, and you can see the moisture is a little bit limited. We've got dew points here, maybe in some locations, reaching about 50 degrees Fahrenheit. So again, this is kind of a little bit of a limitation, but despite the low level of moisture, as we'll see, we'll still have a pretty interesting convective situation. So then if we apply these to things like surface-based capes and looking at the shear, as we talked about in class, these are some parameters that we want to consider and thinking about any convection, but in particular, looking at some of these potential for MCSs. So again, with time, at the 12Z sounding, there was no surface-based cape, but with time, you can see the increase. Despite the marginal moisture, we can see values, pockets of values, maybe about 1,000 joules per kilogram, but mostly a bit lower. But there isn't much convective inhibition in this area, so anything that fires up can just access the full instability that's available. And then, as we talked about earlier, we talked about the 0 to 6 kilometer shear vector. Initially, this was around 37 knots, or as I said, about 1920 meters per second. So this is really conducive for this kind of multicellular mode of convection. But then, as we see over the course of 6 or 7 hours, it's increased considerably. So now you can see it's more along the lines of 50, 55 knots in this region. So there is an increase in this overall shear, partially from the increasing low-level winds out ahead of that deepening trough, but also an increase in the 500 millibar winds over this region. And you can see the direction of the shear vector as well, largely from the southwest. And then finally, we talked a lot about thinking about the storm relative winds, and that's really what we want to consider in some of these organizational modes and subsequent severe weather. So this is, again, at 19Z, so around the time that some of this damaging reports were being, damaging winds were being reported. This is the 0 to 3 kilometer storm relative felicity. We've got the 0 to 1, so the low level, and the wind barbs are showing the overall storm motion that are used to calculate the storm relative felicity. So you can see that over areas here where we saw a lot of these reports, we've got pockets of 200 meters squared per second squared, and then on the lowest levels, exceeding 100. So there is some potential here for the severe weather that we talked about based on the parameters that we discussed in class. And I know I'm going through this quickly. There's just quite a few things I want to look at, but I wanted to look exactly at the component of the storm relative winds, because remember in class we talked about MCSs, and we want to really think about the storm relative winds and how they're encountering the storms as they're moving through. So how strong is that low level wind shear with respect to the motion of the storm? Can it balance out the gust front that's being produced by the convection, such that the gust front will either overrun the convection and make it and contribute to its decay, or continue to promote convective development out ahead of it? So if we keep this in mind as we look at the storms that develop in the Northeast, you'll see the 20 to 25 knot winds, but you'll notice the storm relative component in the lowest few kilometers is oriented from the west to the east. So if we've got that cold front draping across this area and we've got storms moving and propagating to the east. This is that perpendicular storm relative wind component that we keep talking about in class that could potentially promote the continued longevity of these MCSs as they move across the area. All right, so what happened? Actually, let me skip over to the satellite first. This was too big of a loop for me to save. So what I have shown here is the visible imagery, and it's overlaid by the infrared. So you can see the coolest colors with the deepest, associated with the deepest clouds. And the loop goes from about 18Z to the end of 21Z, so about 22Z. So you'll notice initially, you can see the storms that are firing up along the cold front. They're not all particularly very deep. There's some pockets where they're deeper down near the Delaware region where they had produced some hail. There's some deeper echo here that was associated with the portion of the storm that spun up a weak tornado. But you can see that overall, there's not completely unbroken, but we've got a substantial line of convection moving across this area, across the cold front, but not especially deep across the whole region. That was limited in somewhat by the instability. So I just want to show now the corresponding radar loop. So this is zooming in space and time. So we're looking here as the storm moved across Connecticut and Massachusetts. And so what's shown here is the radar reflectivity and the radial velocity. And you can see this very classic squall line structure that we talked about in class. You can see some of the variation in terms of potential areas that have this slight blowing structure moving outward. So perhaps the most intense winds are forming in this region. And sure enough, if we look at the radial velocity, you can see the very high inbound winds right behind in this notch behind this blowing area of the reflectivity. So the other thing to point out here is if you watch very carefully with the storm relative winds, you can see the motion that is stronger than the mean flow associated with the motion of the storm. So this is the representative of that gust front that's moving out ahead. I mean, you can see the continued convective initiation here ahead of that gust front because you had the strong enough perpendicular storm relative low-level winds to promote that convective initiation. So I just wanted to very quickly zoom in to look at actually the magnitude. So remember, we've got this deep layer shear that was increasing with time, and the actual winds in this area, are exceeding 50 to 60 knots. And then if we look at the surface, it translates through this rear inflow to this near surface. Remember, this isn't looking exactly at the surface, a 60-mile-per-hour wind. And then indeed, at the surface, there were winds exceeding 60 miles per hour in this region. And then I just zoomed in. I didn't really analyze this too much, but this was the time of the tornado that was near Amenia. So the actual text of Amenia covered up this very weak couplet that could be seen higher up along this line. So this did produce spin up a tornado earlier on and further to the west. So in the interest of time, I want to make sure we talk about other things. This was just a kind of a fun example to apply some of the things we talked about in class. And I will stop sharing here so you can take over, Michael.
Okay, thank you, Angela. But just a quick, any questions or comments?
I have a quick question. I know we've been talking about bookend vortices in class. Was that an example of one in that radar image that you were just showing?
Yeah, but sorry, Benji, let me share again. I should just keep the screen up. Can you see my mouse?
Yeah, I can see it now. Yeah.
So this is the area that we would be referring to. This isn't really a very strong flow echo, but this is that region that I would be that we were referring to, kind of on that northern of that cyclonic end. Do you see where I'm pointing?
Yeah, I see that. Yeah, I see that.
Yeah. Okay.
All right. Thank you.
Yep.
Okay. So next we're going to talk about a rather amazing event. This is Typhoon Sergey. that formed well over a week ago and was forecast to form actually several weeks before that. So really an incredible feat of numerical weather prediction, and to give us 10 or more days lead time in the emergence of a rather extreme tropical cyclone in the West Pacific. On Saturday, the storm deepened in terms of intensity. The wind speed increased over 105 miles per hour within over a 36-hour period, topping out Saturday afternoon, our local time, at 190 miles per hour with the winds. So this is something that, run-of-the-mill mid-latitude cyclone would never achieve, John. But in any case, rather intense storm. And the storm, we'll look at its location today and talk a little bit about its potential impacts in mid-latitudes as it drifts northward. But I want to say a little bit about its track and some other features of it. But this is a satellite composite from Central Africa all the way out to the Central Pacific. And you can see smack in the middle of this is Surigai, also known as Bising by those in the Philippines. This is the second typhoon of the year. It's only 4 other storms in the tropical cyclone record have ever achieved this intensity. And this is the record in terms of having reliable observations or estimates of cyclone intensity, only 4. And it's also has the distinction of being one of the, it's the earliest, strongest storm before May, I believe, in the Northern Hemisphere. So this is an incredible feat, and one that, again, NWP guidance, whether it latched onto something correctly, but it kind of pointed out the prospect of this happening. I think that's pretty incredible. From this morning, you can see it doesn't look as robust. It's now has winds, top sustained winds of 80 miles per hour as it's moving to the northeast. You can see the island of, Taipei or Taiwan, and you can see the Philippines are down here, and you can see the southern edge of some of the southern islands of Japan on this feature, or on this particular image. And you can see this broad center of the cyclone with most of the deepest convection isolated to a region to the north and northeast of the presumed center of this storm. And a broad cloud shield looks almost extratropical at this point. This is another image from earlier this morning as well that shows the structure of the cyclone. The prior image was an infrared image, so these brighter tops indicate very cold cloud tops, and again, deep convection. And the lower clouds are obviously these grayer or less intense, less white images, parts of the image that you see here. Here's visible imagery taken from earlier today that shows, again, that structure. So a nice cloud head to the north, a lot of dry air perhaps coming around the southern edge of this particular cyclone. Let me go back, wrong direction, sorry. Gotta move my mouse over. The eventual track, this is the earlier part of the track. We'll see the past track in just a moment, but you can see the track took it just to the east of the Philippines, and that was actually well forecast by the GFS, the global forecast system, NOAA's global forecast system. I think the Eastern WF a week ago had it coming a little bit closer to, or even impacting directly the island of the islands of the Philippines. But you can see it has since it stayed to the east and is beginning its recurvature eastward. And it's been a slow track. You can see these points, which I think are about every 6 hours or so in position. It's been or every 12 hours in position, just slowly moving northward east of the island. 75-foot waves were generated in the open ocean associated with this tropical cyclone. And then these plot points that you see that aren't filled in just kind of show the expansion of winds of different intensities and the radius of winds out to a certain distance, and give you sort of an envelope of where the cyclone is expected to be over the next, through the 26th, over the next 3 days or so, as it drifts south of Japan into the Pacific. And what's going to be really interesting is what happens after that. But just to give you a broader track, idea of the evolution of the track, started off as a weak cyclonic center out over the Pacific, well east of the Philippines, and then just drifted northward, and again intensifying middle of last week, and then rapid intensification during the day on Friday into Saturday. Peaked out in intensity, really intense storm. We'll see some satellite imagery of that time period, and then began a weakening phase, becoming more of an annular storm. So this is Saturday. You can see a really robust cyclone with a well-defined eye, very cold cloud tops from this enhanced IR imagery. It's a cyclone, just a beautiful looking storm and well-developed eye, nice outflow in pretty much all directions. This is just incredible as it was peaking out at roughly 190 mile per hour winds. The visible image from this was on the 21st, so it's a couple days ago actually. So again, it maintained a pretty decent intensity through just the last couple of days, and it's again weakening now, but it was still roughly a Category 4 equivalent typhoon just on April 21st. And displaying annular characteristics. And I would note, again, I wish I had the forecast data to look at from a few weeks ago, but that was actually in the cards. The GFS actually had it transitioning from sort of a nice tight cyclone to a more annular storm. And this was accomplished following what's called an eye wall replacement cycle. Now, whether the GFS was even capable of producing such a replacement, it did have a change in the structure of the storm to something more annular. Did it quite get all the details right? I can't speak to that at this point, but again, just a really fascinating development with this storm. Okay, so this is again just a couple days ago what the cyclone looked like, and as I said, now it's a ghost of its former self. So what's in store for this as we look forward to the next few days? Here's the GFS forecast initialized from 12Z this morning. You can see a parade of cyclones across the Pacific, but here is Surigai, again, just south of Japan and to the northeast of the Philippines, analyzed in this at 976 hectopascal for its central pressure. And we'll step forward and see how this cyclone evolves over time. Another thing to note in this image, just follow the progression of this area of rather cold, low values of thickness, sub 516 thicknesses over Eastern Asia. And we're going to see there's going to be interaction between, I'll just call this very loosely a broad weather system that's well to the north, and this tropical cyclone to the south. And we'll step forward. It's really through 84 hours when we get to that interaction. So it's kind of lumbering along at 986 and 987, 988. Not much going on, but I'll go back a few steps. Just note this trough in the thickness field as it dives southward across northern Japan, Hokkaido. As this moves northward, you can see a rainfall event that begins to occur just ahead of the upper trough. And you can also see an elongation of the cyclonic circulation in this image. I'll move this up a little bit. An elongation of the cyclonic circulation in this image. So in last couple of forecasts, we've begun to see this interaction noted in the models. If you went back, and we'll go back very briefly, 4 or 5 days, this didn't actually occur, something a little bit different. But even in the forecast over the last 3 model runs, we've seen some differences. We see this cyclone kind of spreading out, stretching out with a northern center, the center kind of appearing to jump to the north and interact with this upper trough. Last night's 6Z run actually bodily took the cyclone northward fairly rapidly and not with any apparent relocation of the center to the north. It just seemed to propagate wholly to the north. But this is the 12Z run, 994, and you can see there's the jump, right? There's the old cyclone center down here, still a maximum in geostrophic vorticity, but there's a favorable region for the cyclone to jump. So that's 993, 988, 982, 974. Again, we're just dropping, that's, again, between these two images, we're looking at 3 hours. So go from 974 to 964, 10 millibars in 3 hours. John, that just doesn't happen in the extratropics by itself that often. And then when it happens because of a tropical cyclone. But of course, you know.
We're working on a storm off the coast of California over cold water where it goes down 15 millibars in 3 hours. So it does happen. But anyway.
Yeah, but I said, I did preface that with, it's not common.
No, it's not.
But that's true. Okay, 964, 950, another 10 millibars, John. Okay.
That's pretty good.
948. Oh, come on. This is incredible.
It is an amazing event.
Yeah, this is, so this is again, it's well east of Hokkaido. It's in the, approaching some, to the south of some of these islands. I don't know if they're disputed. This would be all Japanese islands. I'm not sure of the ownership geographically, but just a really intense cyclone down to 948, 946.
Man.
And then 947 kind of bottoms out there. Again, it was much more intense earlier in the weekend. It was sub 900 last weekend, but this isn't too bad for a mid-latitude cyclone. So we have an extratropically transitioned cyclone, really intense winds, broad wind field, certainly much broader than it was when it was in the tropics, and it's certainly wreak havoc for shipping interest in this region. If we go to, I'll go back to the beginning of this, and if we go step forward, I want to just go through this quickly because I know there's other things to talk about. The cyclone begins to fill over the central Atlantic, and then it just kind of peters out, and it may give some impact to British Columbia and southern Alaska later in the forecast period. Again, this is now over a week and a half out, but in terms of its remnants, but not really a big impact. If we look at the up in the upper troposphere, let me go back to the initial time, go to this map. Okay, the cyclone is located here in this region. If you can see the cursor, and you'll watch the evolution of this sort of warm plume. You'll also see the upper trough, the cooler colors. This is dynamic tropopause with potential temperature. And let's just animate it. I'll stop it at 84 hours when we have that nice interaction. Here comes that upper trough, the pink crossing through the Sea of Japan into the West Pacific. And then bang, there's that interaction occurring. Notice the really robust upper wave that forms is anticyclonically curved warmth along the dynamical tropopause. And the other aspect of this that's really interesting is that, again, the gradients of potential temperature along this are going to be associated with a front. You can define a front on the dynamical tropopause, and that's going to be associated with a jet. So as we see these gradients intensify, that's a nice upper front that's forming a downstream of this big cyclonic development. And that can potentially trigger other sorts of developments beyond this time period. Okay. And just to verify,
Michael, I think it would be so cool if an experiment could be run where you take the tropical cyclone out and see what develops with that little thin PV filament that comes in over the Sea of Japan, because it's kind of a wimpy looking feature at upper levels. And if it didn't have the hurricane or remnants of the hurricane, I wonder what would develop. And you can't, and the interesting thing is you can't even see the hurricane in the initial PV map. You don't even know where it is. If someone asked you without knowing, where is the hurricane here? You'd say, I have no idea.
Yeah, you might think it's somewhere down here deep in the tropics.
Right, yeah.
But it's actually kind of nestled right in this area. You can see a little bit of divergence aloft, but it's weak. So here's the jet evolution as well over that same time period. Again, the tropical cyclone is right here. Okay, and we'll just let it animate. Here comes this 500 millibar. This is a 300 millibar jet.
Just FYI, Michael, the animation is not coming through real smoothly.
Okay, sorry about that. But key thing is you can see the downstream jet streak that forms where we got that upper tropospheric front that was forming downstream of the cyclone. And just a last piece for those that are interested in these sorts of interactions. I mean, these have been studied extensively by people like Pat Haar, Heather Archambault, Sarah Jones, and Michael Reamer. This is I just took a couple of images from a paper of Michael Reamer's and Sarah Jones. I'll just bring this up. That actually kind of runs the experiment John was talking about. Okay, this is a baryclonic life cycle experiment in which they take an initial jet, they perturb it to get cyclonic development. The images that you're looking at here is a dynamical tropopause. The thin contours are sea level pressure, isobar at sea level perturbation, the pressure perturbations. And then the thick dark line, if you can see me tracing this out, is the upper jet, so where the jet streaks are. And so these are images that are 36 hours into the integration without a tropical cyclone. Okay, panel A, B, C, D. You can see the development in the central portion of this diagram of that initial cyclone. And you can see some downstream development. This is a recirculant channel, so what goes out on the east comes back in on the west. But you can see the development of this, and you get a parade of cyclones that develop. And so what they did was they took a hurricane vortex, spun it up in a smaller model, a separate model, using characteristics of this low latitude air and ocean that was here, the boundary conditions there, and then inserted that tropical cyclone in at 36 hours. So at the time of panel A. So there's the cyclone. And you can see at the time that this was inserted, or they let it spin up to this time. So at 36 hours, you can see that, again, that robust jet streak that forms at high latitudes to the northeast of the tropical cyclone, the downstream development. Not much of a cyclone yet there, but you can see that the tropical cyclone shows up nicely. And these are every 36 hours going forward. So this panel is at 108 hours. Oops, excuse me. And you can see this is the transition to tropical cyclone, but here's the downstream cyclone that develops. And again, there's the transition cyclone and the subsequent downstream precursor. If I flip back and forth between these, you see a more robust development downstream when you have the tropical cyclone. That is basically a statement extratropics needs the tropics for some interesting weather. And John concurs with that. And then you can sort of see the final wrap up. But at the end of this, in this particular cycle, the differences aren't, I would say, super significant at this point. I mean, obviously you do see in the medium range, there's certainly a big interaction, but it seems to get washed out, and maybe virtue of the fact that this is within a channel model. But great set of papers to look at. I'm only just looked at the very thin top of the edge of the knowledge that's in here, but it might be interesting if you want to follow that up. I can send you the links to that paper. Anyway, thanks very much, and I'll turn it over to John.
Thanks, Michael. That was really interesting, if editorialized.
Just a bit.
Let me share this, and I'll go as quickly as possible through the current weather. So here's the screen. So let's take a look at the first thing is our satellite movie over the continental United States and adjacent waters. Here's the storm that Angela was talking about when it was in its infant stage, trying to get itself organized just 2 days ago along the northeast coast of the United States. It's blossomed into a really beautiful occluded storm. It'll make a little bit more of an appearance in my discussion in the next few minutes, but you can see the convective activity along its cold front is considerable, well out to sea, cold air funneling off the continent, evident in the stratocumulus that you can see right off the continental shelf waters. It's really dramatic. And then really wound up north of the Maritimes in Canada. So a pretty interesting storm. And there's widespread cloudiness and a few right there in central Texas, a little bit of convective blow up at the last minute, seems like right there. And that's kind of this is a day, I think day one, SPC has some warnings out for mostly hail and heavy winds, not really tornadic storms, but some interesting weather over Louisiana, parts of central Oklahoma, and parts of Arkansas, and even eastern Texas. So that's starting to blossom as we see it in the satellite right now. Then we've got a cyclone just to our north and west that has spread clouds over our skies in the last couple of hours. Looks like the weather will deteriorate, although even tomorrow it's really only a 30% chance of showers. I think there's a guarantee we'll see a rain shower tomorrow, but temperatures in the mid 50s. But it won't be remembered, I don't think, as a rainy day. It'd probably be more remembered as a cloudy day with a sprinkle here or there. I hope that's the case. I'd like to get out and do some things around the yard. But anyway, that's what it does actually look like that. So there's reason to be encouraged about that forecast. And then over the Intermountain West, one can see some clouds developing over the high terrain. Probably they have a little bit of a convective character over Colorado, parts of Wyoming, and maybe even New Mexico. But that's somewhat independent of what's developing further to the south and east of there. And then the Pacific Northwest has had a beautiful week, actually. It's been a gorgeous last 7 or 8 days. Maybe finally clouds coming in to the Pacific Northwest and some light rain. We'll see some reason for that later. You can't see very much else into the Central Pacific Basin, but it's worthy of some discussion. So we'll go there in just a minute. Here's a map that I'd like to start with to give a complexion of the various weather features across the continental US. It's from Alicia Bentley's fine set of maps. Here's the cyclone over the Gulf of the St. Lawrence. It was down to about 978 or so this morning. This is from 12Z this morning. And you can see the thickness field in blue and dashed red, dashed blue too, kind of coming back up. There's a nice thickness ridge. In fact, I'll show you later evidence for an occluded type structure over the northeastern part of Canada that is, I think, fairly convincing. Here's a strong frontal boundary across Hudson Bay and across Saskatchewan heading southeastward towards us. That's a fairly substantial temperature contrast. It shows up even at 850. So it's not just a column average intensity. It's kind of got a deep structure to it. And then a big anticyclone over the southeastern United States, ushering the cold air we saw on the satellite picture with the stratocumulus off the northeast coast of the United States. And then, of course, return flow of warmer and more moist air into the central plains. And that may fuel some of the interactions with the advance of this cold front that we experience tomorrow. So we'll have some interesting interplay there. And then off the coast in the western United States, Gulf of Alaska region, probably some of the excitement of waves that is only beginning to show up now as Surigai and it moves into the mid-latitude jet. Were it not, all joking aside, were it not for this PV filament that we just saw from Michael's analysis coming down southward, almost straight southward across the Sea of Japan from eastern Siberia, I don't think that Surigai would have the impact it's likely now to have on the Pacific jet, because it did seem to just, in last week's forecast, and even earlier in this week, as Michael pointed out, it did seem to hit a bald spot in the PV gradient along the tropopause. But when other features come in and kind of act to, deform that tropopause structure and massage it, like apparently is going to happen, that's a whole different story. So we're really going to see some interesting weather there over the weekend and into the early part of next week. So that's exciting. And thank God for the mid-latitudes. If you didn't have that mid-latitude savior coming in, Surigai would be all over. So, but it's not. So there's more to see. Here's the radar across the continental US now, and you can see some of this convective activity that's in the day one SPC forecast is starting to show up in central Texas, and not quite yet in Louisiana, Arkansas, and central Oklahoma, but I think that's yet to come. And you can see echo coming across us. We had an 18-degree dew point depression this morning at the surface, probably through a reasonably deep layer of the boundary layer as well. And so it's going to take a while to moisten the column before any of this rain comes in. And we don't really have a well-developed cyclone to our west that's starting to fill in a little bit better in Minneapolis and to the west. So I like that forecast of 30% chance of showers. I think, as I said, I think it will shower tomorrow. I'm just not sure it's going to be something that makes the whole day feel like a rainy day. It's just not put together yet, and it doesn't look like it's got the right structure to do that in the longer term. Pacific Northwest, no rain yet, but you can see a little bit of echo coming in well off the coast of Oregon and Washington. So this must be a little more intense than it actually looks. So it'll probably rain later on today in those locations. And then you can see the popcorn cumulus showing up as probably light rain showers over the Colorado Rockies, also into western Wyoming and eastern New Mexico, as appeared to be the case in the satellite. Okay, I wanted to show you this and a couple of upper level maps. I'll start at 850 because, and this is from 12Z this morning. Here is the isotherm structure, and there's the minimum in geopotential sitting over the Gulf of St. Lawrence. And you can see a thermal ridge come all the way back around to about this point. Then there's a nice baroclinic zone for the cold front that goes down, arguably across the panhandle, western panhandle of Florida. And then there's not much thermal structure at 850 for the warm front, but you'll see I'll analyze an occlusion and the warm front sticking out to the east. And here's the next baroclinic zone. Look at how sharp that temperature contrast is in western Manitoba. That's 15 degrees across a really small distance there. I'm sorry, that's Ontario. A really small distance in the northwest portion of the province with a very sharp wind shift. Here's the little bit of geopotential minimum and the circulation center for that weak cyclone, the evidence of which we saw in the precipitation at and west of Minneapolis. But this boundary is tied to a cyclone over the archipelago, which has very little oomph to it, but it has a really strong cold frontal structure to it and strong cold advection now invading into northwestern Minnesota. And that will be part of our weekend weather story, it looks like to me. I think let's also take a look at, while we're here, let's look at the 500 millibar map. And there's our deep cutoff over the Maritimes. And one can still see a very intense baroclinic zone, even at 500 millibars. If I had a pencil and paper, I'd probably analyze this without this wiggle. Why is that there? There's nothing to support it, make it look a little nicer. And so, but it's as cold as minus 32 where at 500, where we're seeing that stratocumulus coming off the Atlantic, northeast Atlantic coast. So it's very chilly aloft. And I'll point out, when Angela was talking about the 2 days ago on the 21st, it was notable that we had a minus 34 isotherm over us, a big pocket of really cold air when we had our convective snow showers on Wednesday. And we had a little bit of it on Tuesday too, in slightly warmer air aloft, but they were more intense on Wednesday. And we had observed lapse rates on the order of 7 to 8 degrees C. So any little moist possible was freely convective. And we saw the results of that at the surface. At 500 millibars, this is a cutoff, almost equivalent barotropic structure over the archipelago. Probably the reason why there isn't much of an obvious cyclone to its south. The baroclinic zone is continuous from 850 all the way to 500. That's clear in this analysis. And then we've got this troughiness in the central Gulf of Alaska with the little bit of ridge preceding it, which has ensured pretty nice weather over the Pacific Northwest today. And this trough over the northwestern states of Mexico is part of the story for the expectation of some severe weather. Again, not tornadic, but winds and hail across the south central plains. It's kind of a perfect setup. You drag out the elevated mixed layer, you then have a forcing for ascent, and you have the return flow in low levels moistening the lowest part of the atmosphere. It's perfect combination for producing some at least lightly convective and moderately convective storms. And then the last thing I'll show from this set of maps is the 300 millibar map. And there's our jet kind of off the coast, tied to the cold frontal structure associated with that cyclone. This is a weak flow, about 108 knots is the max right there in central Alabama. But that's because it's really the underlying, the underbelly, I guess you could call it, of the subtropical jet. If you go to 200 millibars, it's considerably stronger. 153 knots near Atlanta is the maximum. So it's a really strong subtropical jet over the southern states today. And look at this thing. I mean, this is 170 knots from the northwest, from, from the date line. What's going on there? Let's go back to 300, see what it was there. I forgot now that I mentioned it. Yeah, it's not as strong at 300 millibars. So that's like a subtropical jet. That Surigai's already kind of screwed up the Pacific Basin flow a little bit. And it might get worse as the week goes on, as we just saw from Michael's analysis. Okay, here's the West Coast satellite image. Oh, you know what? Before I wanted to show you some evidence of what was going on with that cyclone. Where is that? It's not here. Son of a gun. I guess I got to share something else. You know what? Here it is. Yeah, this is it. Can you see this? This set of maps? Or do I have to share another screen?
No, I
You
think
just
you're
see
just
the
sharing.
satellite.
Yeah, you're just sharing the web browser.
Okay, I'm going to share something else. I just want to show you this. Here it is. Okay, sorry. Thanks for telling me that. So here's the cyclone that I was talking about, and Angela had begun a discussion with, and it's 978 or so, right there at the Gulf of St. Lawrence. And so here's the occluded front, the cold front, and the warm front, and there's 1,000 millibar geopotential heights at 12Z yesterday. And so here is an interesting analysis that one can do. This is the 1,000 millibar position of the 309 degree Kelvin moist isentrope. This, and then I'll put the cyclone frontal structure in a light gray. This is the red line is the 900 millibar position of that same isentrope, 309 Kelvin. Here's the 800 millibar position of it. And you can see what's happening. You get this butte in this 700, 600, 500, and 400. You get this beautiful thermal ridge that goes right up along the occluded boundary. And this is really the essential structure of an occluded system. It's this three-dimensional upward sloping canyon in the theta E surface. Somehow I just moved that. I'm sorry. I'll just undo the move. So it's this beautiful trowel structure that's really evident. It's got this extra appendage in middle and upper troposphere that is kind of over parts of northeastern Canada. I don't know what that's all about, but you can see a really nice occluded structure associated with this cyclone. And this is the one that developed rapidly from its rather meager beginnings, associated though they were with some severe weather along the East Coast that Angela started talking about at the beginning. So let me go back to my web browser and I'll finish up. It must be this one right here. Yeah. So I wanted to finish with the West Coast satellite image. And here's one of the cyclones that Michael just showed us. It's not the one that's currently, right next to Surigai. It's downstream by a whole cyclone. So this is one of the three. I think he showed a series of three. This is the leading one, the farthest east one. And it looks pretty intense. It's almost at the date line. And it's pretty intense. This is just a tropical plume out ahead of it. The Pacific Northwest is relatively boring today in the Eastern Pacific Basin, but that won't be the case over the weekend in the early part of next week. So things are about to change. Oh, this was the Surigai. I didn't know at the time I had it ready in case Michael was unavailable. So that's all I have for my part of the discussion. Sorry it's taken so long, but I'll turn it over now to Alex.
All right. me put it into present mode. Hopefully all looks good.
Yeah, we
Okay,
can see it, Alex.
okay, great. So as Professor Martin sort of precluded, there's some interesting weather happening along the southern plains and into the southeast US. This is SPC's outlook for from 1630 to 12Z tomorrow. And we see that there are, a couple enhanced regions of severe activity over south central Oklahoma and then east Texas into central Louisiana and part of western Alabama. And this 30% chance of hail probability that they're putting out, that's new. I had checked a couple hours before this, so they're getting a little bit more confident. But this enhanced or significant hail probability is mostly on this left side from central Texas into southern Oklahoma, along that slight categorical outlook. So here, so on the left, there's the HURRIT initialized at 12Z today, and then the NAM3K initialized at the same time on the right. This is showing reflectivity from 18Z on the 23rd today until the end of the forecast period for SPC tomorrow at 12Z. So there's a lot going on here, but we can see that at the beginning there's the low starting out in central or just south of the Texas Panhandle, moving over and kind of tracing eastward across Oklahoma into Arkansas and northern Mississippi. There's sort of these squall lines that start to develop as the forecast keeps going, as it keeps going along, with more broad precipitation down towards the south across Louisiana, Alabama, Mississippi. And so this is, both of these are for the 12Z HURR. On the left is the 6-hour accumulated QPF at 0Z, and on the right is at 6Z on the 24th. So there's this swath of heavy precip, of heavy rain coming along that enhanced region that that SPC had. So there's some potential for flash flooding in this area.
That's not right.
There's pretty heavy rain within the 6-hour time frame. This is a sounding from Dallas, Fort Worth today at 12Z. So I just kind of wanted to show the environment that these storms are moving into. So as Professor Martin already said, there's some convection starting to pop up around that central Texas area, and you can sort of see why we have really steep mixed layer, elevated mixed layer, steep lapse rates just above a cap below 700 millibars. As that nocturnal inversion starts to mix out, we'll be able to get some, some decent convection. We see veering, more southerly to southwesterly flow, moving up to, just straight westerly almost, and a lot of speed shear throughout the troposphere. And then looking at more of the broad picture, you see, I sort of talked about before, that deep trough at 500 and also at 700, bringing some dry and warmer air from the Central Rockies and from the Mexican Plateau kind of creating like a classic setup. And if we move along to 800, there's just straight westerlies coming off of the Southern Rockies across western Texas, and then turning right into this region into southern Louisiana, southeast Texas. And I guess I should note that this is on the 24th at 0Z for these model images. So we're going to have a lot of moist influx from the Gulf, and as this is around sunset, so as it starts to cool off, we'll see that intensification of the jet around this region, and helping to bring that lower level moisture. And so specifically, this is still at 0Z. This area of convection right near the center of low pressure. And as we'll see on the next slide, it's also located east of the dry line. And so this is the area that SPC had that significant, hail probability put out. And if we look at, where the low is situated, it's, just in the lee of the Rockies. So like I said, we have that dry area there, counterclockwise flow from here. And then we also have this high sitting out along the East Coast in near the Gulf Stream, and you get counterclockwise flow helping to really enhance the southerly low level influx of moisture into the southeast region. And here we can see the concentration of that 850 millibar jet situated right here, and this is also where the warm front is, so able to get a lot of lift and able to get that precipitation in this area. There's not a real well-defined cold front yet, as this area is still rather warm. It's warmer than to the west and to the east. So if we go ahead, we can see the strong gradient of dew points here. So if we go a few counties over, it's 66 here and 19 here, so pretty sharp contrast. And this area along the north central south Oklahoma border is where that convection was starting to kick up. So I took a couple soundings. The left one is obviously west of the dry line, indicated by the circles in the bottom or in the top right. And then on the right is to the east of the dry line. So you see a really unstable environment. So at 0Z, we still have relatively warm temperatures near the surface, and that's the steep mid-level relapse rates that we had talked about before. Lots of veering still, and if we look at some of the actual numbers, the surface to 3 kilometers, 40, 49 knots of shear. So just plenty of deep layer shear, and potential for some supercells to form in this area. Cape values of just below 3,000, and we see the freezing level at 0 is just around hovering just above 700. So with deep convection, you can get plenty of cold air for hail to form. And so this is just reiterating kind of what I said. There's plenty of CAPE in that region just east of the dry line, and as well as deep layer shear. If you saw before, there's on the reflectivity, it wasn't really showing up on the models, but obviously it's sort of happening in real time. There's really not any precipitation around this area. And I can go back to 850, I think. It sort of the boundary where there's a lot of CAPE here, but there's still a lot of drier air coming from the west, maybe cutting off some of that moisture, being able to be accessed throughout the rest of the troposphere. Maybe explaining why the model isn't showing precipitation in that specific region, but look forward a little bit. And so this is at 6Z on the left on the 24th, and then 12Z on the right on the 12th. Just kind of showing the evolution of how we'll progress throughout the forecast period. So like I mentioned before, sort of this squall line coming out over eastern Oklahoma, and then more widespread lighter precipitation around Arkansas and northern Alabama and Mississippi. And then that's going to move into Alabama and Georgia by the mid-morning, or by the early morning, just after sunrise. And the progression of the 500 millibar jet, it's staying rather neutrally tilted with the trough axis, but still blowing plenty of westerly southwesterly flow into the region. And as I kind of mentioned before, the 850 millibar jet really does start to ramp up. You can see in this region at 6Z, just behind the squall line, just how I guess strong those winds are just behind it, helping to push it along. And I'll try and wrap up here because we're pretty much out of time. But it's not a real well-defined low pressure system that's moving along, which doesn't really help with some of the organization up towards the northern parts. But you can see that we still have this warm front boundary, across lower Louisiana, Mississippi, and Alabama. They're going across there, and this is the 0 to 1 kilometer shear around this area, around the southeast, and just kind of showing that there's plenty of low-level shear. If the boundary layer towards in the southwest is able to destabilize a bit more, it might be able to be more conducive to more severe convection. But currently the models are showing more moderate lapse rates. It's mostly moist throughout the profile. So this one is taken on the 24th at 12Z in this area in southwest Mississippi. And so it's really moist just throughout the whole layer. This is the HER initialized at 12Z today, and then this one is comparing the profile with a NAM3K. And they're both fairly similar, where we have, you know, more moderate lapse rates and towards the boundary layer and up through the troposphere. So that's all that I have. Are there any comments or questions? Let me know.
Nice job, Alex. Cassidy had a question earlier about the dry line. You know, I think that was, I'm checking the time. I think you asked that before he talked about that, but Cassidy, do you have any follow-up questions about that for Alex? Okay, he answered it okay. With the last minute or two, who else has a question for Alex about this event? You can put it in the chat or you can unmute yourself.
Angela, I had a question, if you don't mind.
No, go for it.
I wonder what, you know, this whole setup is reminiscent in a lot of ways of the kind of things that we found after Stormfest, you know, these regions of cold advection in the middle troposphere that were out ahead of boundaries like the dry line, and how you can, that can be one of the ways in which you cash in some of that latent instability that's in the sounding. Alex, I wonder if there's any evidence that the mid-tropospheric cold advection, I didn't notice it on the sounding so much, but maybe it's because I was going through them a little too quickly in my mind. Any horizontal maps of mid-level cold advection that are either to the east or right coincident with the dry line at the surface?
Sure. I can probably take a look.
And just one time would be enough. You know, if you, one of the times, I think you had a time earlier on where the dry line was really evident.
Mm-hmm. Yeah, that was at 0Z. So I can.
Okay, so let's look at that time if you don't mind.
Sure. I think that they have it plotted here. And there's severe weather. Okay, we can just look at. Did you want to look a little higher than 700?
700 might work, but this is at 12Z. I think you said 0Z, right?
Oh, you're right. Sorry.
Yeah, it's I don't like shaded isotherms. I just can't make any sense of them off the top of my head. But I don't see the structure that I thought I might see. So the dry line was in eastern Texas, I think, at this time, right? Or maybe
Yeah, it was somewhere right around here.
Yeah, there's no obvious disjuncture between its position and the cold advection. In fact, if one were to be honest, the leading edge of the cold advection is west of the dry line here. I think more like a classical type structure. Nothing about the dry line's classical. That's not what I mean to imply, but you have a surface pressure trough with the mid-tropospheric cold advection back behind it to the west. That's classical. And so, yeah, I guess it doesn't have that structure. Thank you for showing me that.
Of course.
I don't see any other questions. Andrew just posted, I haven't read it yet, a comment in the, Andrew, did you want to just chime in and say, in case that everyone doesn't read it?
Yeah, just real quick, it looks like, you know, moving into the early to middle part of next week, there'll be an ejection of some sort of trough out of the Rocky Mountains, kind of desert southwest over the southern plains and southern Mississippi Valley. And, you know, right now, you know, the model spread is still a little wide in terms of timing, but all the major models tend to agree that Tuesday, Wednesday, you know, you'll have a pretty good system moving across that area. And then both days probably a threat in some sort of capacity for severe weather. I know the SPC already has a 15% out for Tuesday, kind of across the Red River Valley. And then really it's a matter of timing in terms of what Wednesday could look like. Some models keep the trough a little further to the west while others progress it into the Mississippi Valley. So definitely it looks like it'll be turning a little more active moving into next week. And I think, at least for us, that means a warm up as that system also kind of makes its way out and we feel the effects of it. So definitely some interesting things to watch moving into the early half of next week.
Yeah, thanks, Andrew. It'll give us some more things to talk about during next week's Weather Watch. A little more active again. Well, Alex, thanks for a great discussion, and just in the interest of time, don't see any other questions. I think we'll wrap it up on our end. Thanks.
I have a quick comment. Going back to what Michael was showing, what the tropical cyclone. If you look at SSCC's tropical page where they have this track, you can really see some strong evidence for upwelling with the cold SSTs behind the track. Where it's very obvious on it, which is a cool example to see.
Zoe, do you want to post the link in the chat so everyone can kind of follow along?
Yeah, I can. I think you'll have to click along. That's the
I just made you a co-host too, Zoe, if you wanted to share the screen.
Yeah. Can you see it?
Yep.
Yeah, so this is the storm Michael is talking about, and the track, if we put IR where it is right now, but you can see in the wake of it, if you look at the sea surface temperatures, that really strong minima in sea surface temperatures indicating all the upwelling that occurred, ocean upwelling, colder water that has passed through. You can also possibly see that in the minima of the ocean heat content as it moves through. It's a nice example.
Yeah, thanks for sharing that with us.
Yeah, that was cool.
Bookmark that link. Thank you. Anybody else have anything they want to talk about? This was a fun one today. There's a lot of interesting things to discuss.
Yeah, it's been a series of them, if you ask me. It's been really interesting that we keep getting a nice mix of various kinds of features, but we didn't expect we'd get a tropical cyclone or a super typhoon in early April. So yeah, that makes it. And it's going to continue to next week. We got to talk about the transition next week. So we already have that guaranteed. And Andrew's suggested there's some severe weather, and then maybe there'll be some severe weather from the wave amplification from this transition by Friday next week. Who knows? I mean, it's going to be wild. So always, and it'll be our last one of the semester next Friday. So we'll go out with a bang. That seems to be certain. So.
Well, and there's no other formal forecast briefings from class. So it's wide open next Friday for everyone. One other thing I wanted to comment, I don't know how, obviously you don't want this super typhoon influencing and hitting land, right? But
yeah,
I don't know if you've been keeping track of the extreme drought that Taiwan is experiencing and the water rationing and everything that's happening right now.
Oh, I didn't know.
Last year, the Mayu, we were supposed to have a project last summer, but the Mayu moved north way early based on climatology. So they didn't have that component, and then there really wasn't any landfalling or near enough typhoons to really give much water. So anyway, I just wanted to bring that up. It's a little kind of tangential to what we talk about here, but it's been really, really tough to see kind of the strain that they're experiencing right now, a place that you don't often think about, drought being such a large concern. So of course I didn't want this to hit, but it'd be really nice if they could get some rain soon.
Yeah, wow, that's amazing.
What's the timing of the Mayu for this year, or is it already passed?
It would be later May, mid-May to into June. So I mean, plus or minus a few weeks, but it's still a bit early to see. So we're really keeping a close eye on that going into May.
Wow.
Yeah.
Very interesting. Yeah. Michael, since you're still here, I don't mean to drag everybody into this conversation.
I'm going to take off, but thank you.
Stop the live stream.